There you go. I'm live. Good. So the project. Your project is due Monday at 2 o'clock. Obviously, there are questions that have been asked of me, and I've been answering those questions through email and in person. Tomorrow, same deal. If you have those questions, I can answer them in person, especially when we're doing our Google Meet. Or if you want to ask it separately or whatever, that's up to you. If you ask me a question over the weekend, what's up?
Oh, no, I'm just saying where you're going to go.
Oh, nice.
It's just a game.
Nice. That's a weird game. I think I won.
You did.
Nice. If you try to email me this weekend, sorry, now I'm paying attention to it. If you try to email me this weekend, I will not be available. I will not be able to access much of my electronic devices this weekend. I will be away camping somewhere in the wilderness. So if you try to email me, I won't be able to get back to you. I won't be back till Sunday night. Please do not wait until Sunday night to start this thing. Please do not wait. Please do not wait till Monday morning to start this thing. You guys are Thursday kids, so you're here, what, Tuesday, Thursday? Cool. Don't wait till Monday. Gosh. Hopefully you've started already. We'll see what happens. Anyway, but those are the two big things due for me. Furthermore, do you guys know what the deal is with Wednesday? You're not supposed to be here Wednesday, typically, but you know what's happening this Wednesday. Thank you. PSAT, SATs. For those who have signed up for the SAT, they have juniors and seniors taking the SAT. For all of the other juniors, they have you taking the PSAT. And it's all on that Wednesday. Sophomores and freshmen should not be showing up to school on that day. They won't have regular classes on Wednesday. Now, that doesn't affect us on Thursday, thankfully. On Thursday, we will have regular class, but I'm going to tell all of my Wednesday kids, hey, you better show up for the Wednesday live or Thursday live stream. Yes. Here, I'll show you the email I got.
Is it like all of them?
No, all of them.
Oh, great. I get to see it.
Yeah. Kind of. Here we go. Here's the email. As Mr. Gee said last Friday in his email, next Wednesday, the 14th, we'll be administering the PSAT. The SAT are for seniors and juniors who signed up for it. PSAT, all remaining juniors. A read day for all 9th and 10th graders, regardless of their groups. Since it'll be read day for anyone not taking one of those two exams, all staff will be involved with either proctoring or hall monitoring. As in years past, we'll have 2 proctors per testing room to share the testing, blah, 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 blah. And they have proctoring responsibilities. So.
And they want to give us a PSAT.
I know. Because apparently, here's the fun fact about teaching.
Yeah, they messed it up.
Well, here's the fun fact about teaching. Well, yes, they did, actually. You heard about that?
Yeah.
Nice. Yeah, I was going to tell you the same thing, actually. But I'll still do my spiel. But anyway, for teaching, when you become a teacher, when you're training to become one in college, and you go through all of your education courses, they keep trying to drill into your mind, less testing. Don't do that much testing. You want kids to learn kind of organically. You want kids to learn this way. You want kids to learn that way. A lot of theories and blah, 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 and self-discovery. And then when you become a teacher, it's like testing.
I would like to actually get a feeling. I mean, I'm not learning anything. I'm just trying to pass.
But you're learning to be my friend.
Well, honestly.
You all heard how he just insulted me?
Every single student isn't learning anything with this. We're really just getting a grade to pass. That's literally all our objective is.
Well, I would beg to differ that in my class, you are learning mathematical principles that you may or may not be familiar with, but more importantly, you're maybe learning a different style of learning, a different style that you may not be. I don't care about other classes. Math is the only subject that matters. Anyway, think about it. History is written by the winners. Science, you don't have to be exact. English is a made-up language. Come on. In terms of benchmarks, let me tell you how it all went down. You probably already know, but let me give you my spiel. It was like, hey guys, give them this benchmark at the beginning of the year. It's like, okay, we'll give them this benchmark. Well, what's this benchmark on? It's on prior material. Okay, it's on prior material. So they're Algebra 2 kids, meaning the prior material, you should be taking a geometry benchmark. Okay, fair enough. Yeah, cool. No, give them this benchmark. it's on the prior material. But no, it's not on the prior material. If you actually look at the questions, no, give them that benchmark. But the material on this benchmark is Algebra 2. You said prior material. No, give them that benchmark. Fine, we'll give them this benchmark. And then you all took the benchmark and you saw how garbage that was, right? And then all of a sudden it's like, oh, mistake. Here's another email. We have made a mistake. You actually have to give them the prior benchmark. I want to punch the computer when I see stuff like that, but it is what it is.
Yeah, you teach them pop up. I got 5 projects.
Yeah, fun stuff.
Lives.
I like projects.
Not even just French, you, history, APP, and English.
I love human geography, number 1. Number 2, French is hilarious because they always surrender, That
sucks.
No, but I do love human geography, though. I took a class on that in college. Anyway, back to this. So just those reminders, of course. Number 1, you have that Edulastic thing due tomorrow because grades. You're right, though. It's really messed up. They do give us a minimum number of minors and majors that we have to get in. I should be able to run my class the way that I see fit. Yeah, I agree. No, they do know something about teaching. Most of the people in charge used to be teachers. I know. I just wanted to clarify that.
Now it's really just
I just wanted to clarify that. So, good at taxes. I just use TurboTax, dude. TurboTax. Anyway, you'll learn about it one day. Because everything trickles down. You ever hear the phrase, and I think I used this phrase yesterday, you ever hear the phrase, crap rolls downhill? Anyone heard the phrase, crap rolls downhill? If something happens at the top, that they make a decision or they make a mistake or whatever it is, it doesn't matter what it is, the crap rolls downhill. The crap rolls onto the administration, the crap rolls down onto the teachers, and then eventually the crap rolls down onto you after it has rolled over all of us. Back in 2001, there was a federal law passed called No Child Left Behind. You ever hear of it? The idea of No Child Left Behind, their intention was to get every single school in America up to snuff in terms of passing. Basically, in the 90s, we realized, oh crap, America isn't as smart as all of these other countries. America's ranking like 25th in science and 30th in math. It should be higher. So how do we get them up there? I know, more testing. No Child Left Behind. Basically, every state was then thereafter required to have a high stakes test in order to meet graduation requirement. So all of those years of teaching me while I was in college of don't teach to the test, don't teach to the test, don't teach to the test. You become a teacher and it's like, no, we need them to pass this test. Otherwise we lose funding. Yay! Federal Department of Education. Anyway. That's funny. Eventually you'll learn that. Ladies and gentlemen. No, I said eventually. I didn't say a class. I said eventually you'll learn it.
Yeah.
You'll learn it the hard way.
Exactly.
I learned it the hard way.
That's not smart. It's not good.
Actually, you know why it's good? Kind of to an extent. Let me explain why. By the way, I'm passing out a worksheet. For those of you in the chat, there is a PDF in the Google Classroom that has this worksheet attached to it. So if you want to follow along with some of the problems that we're going to do, you can use this worksheet. Here we go. Oh, I'm sorry.
Thank you.
Oh, that's weird. Oh, I'm sorry. Wait, so did you get one?
Yeah.
All right, whatever. Anyway, so in terms of buying a house, yeah, they don't teach you how to buy a house. That is not one of the prerequisite skills for graduating high school for a couple of reasons. But in mathematics class, you learn this concept known as problem-solving skills. You are faced with a problem. You look into your tool bag and see if you have anything that could potentially solve said problem. You attack said problem with the tools that you have. You see if it works. If it works, great. Maybe you could do it better. If it doesn't work, okay, let's go back to the drawing board and figure out a different strategy for attacking said problem. Now, I just described something that could be described solving a math problem or solving a life problem. Because when you go about the process of buying a house, yes, you may not have learned how to do that in high school. Keep in mind, not everyone ends up buying a house in real life. But if you go throughout if you haven't gone through the process of buying a house, perhaps now you have the skills of seeking out the resources for buying a house. Perhaps you have made the connections and are asking the right questions in order to buy a house. And eventually, through sheer grit and determination, perhaps you have the motivation and the perseverance to go through that process of buying a house. Those are skills, those life problem-solving skills. You refine them in math class, more so than anything else. But that's just my opinion. Not that I've actually lived through any of that. Ladies and gentlemen, I'm going to show you something on Desmos. You know what Desmos is? Desmos is amazing. Check this out. This is going to be the intro to our lesson today. Desmos. I once had a Twitter conversation with the guy who programmed Desmos. It's pretty cool. He was trying to explain to me how he figured out random factors in order to get certain things to fall. But it's a very intuitive program. Check this out. What I've just typed in, I want you to see this. What I've just typed in is the generic form, the standard form of a quadratic equation, ax squared plus bx plus c. And what's really nice is that in Desmos, if you use letters other than x and y, they give you the option of throwing in these things called sliders, which is nice. Now, what you see on the board right now, this red quadratic, is with a, b, and c equal to 1. So this is the equation y equals 1x squared plus 1x plus 1. And I can change any of those numbers. Tell me, where does that quadratic cross the x-axis? Wait, say it again? That was the second thing you said. Where does it cross the x-axis? It doesn't. It doesn't. Now that is key. It doesn't cross the x-axis. See, the thing is, we have been solving, for the past several weeks, we have been solving quadratics. Now, on the Edge-Elastic assessment and on the project that you're doing for me, you are solving by factoring. But on this, we're going to take it a little bit differently. We're taking a sidestep to solving quadratics. I say a sidestep because we're not going to be solving this by factoring. We're going to be solving this by doing something else. Let's talk about it. This does not have any x-intercepts. X-intercepts, zeros, roots, solutions. They're all the same thing. They all mean the same thing. If I say solve the quadratic, I'm really saying find the x-intercept. This one has no x-intercepts, which means it has no real solution. No real solution. We'll talk about that a little bit later. But let me mess around with this thing a little bit more. Check out these slidey things. I love these slidey things. I'm going to take you back to geometry, to a time that you probably wish you were never in. Check this out. Whee! In geometry, do you know what this is called, what I'm doing right now? Sliding was the informal name. Do you know what the actual definition was for geometry? Transformation included all this other stuff. This was called a translation. Yeah, this was a translation. Translation was one of the many transformations that you could do. But if you change the C value to, let's say, -6, now all of a sudden, look at that junk. You change that C value to -6, now all of a sudden you got x-intercepts. In fact, this is the equation y equals 1x squared plus 1x minus 6, because I changed that C value. You could solve that. You could solve that, let that y value equal 0, because you're finding x-intercepts. Oh, dilation. Dilation was one of them too, but this wasn't a dilation. Like bigger or smaller like that. Yeah, you just got to fill this out for me real quick.
I'm sorry about this. Do you think I
Absolutely. I do have pencils and erasers up there. All right, cool. You fill that out. I'm going to take this and go over here. Here we go. Good. Now back to this. Where'd my pen get? No, I need this one. Here we go. So this right here, we can factor it. If we were to factor it using that Tucker method that we would typically do, we would get our two answers of -3 and +2, which you can see right there, just by changing the C value. You know, it's really cool. I can actually do this. Check this out. Hold on. Click. There we go. Look at that thing. I can make it slide. I can do a lot of different things. This is so cool. Watch this. I can pause that. I'll put that back to 1. Watch the B. I'm going to make it slide with the B. Look at that thing. Look at the value of B. Now this thing is really nice because I can actually pinpoint when it has solutions and when it doesn't. Oh, I'm sorry about the glare. Yeah, trying to avoid the glare. Like watch, it has no solutions. Has solutions. No real solutions. Has solutions. No real solutions. It depends on whether it crosses the x-axis. If it crosses the x-axis, then visually, yes, you have two solutions. Now check this out. Let's go back to here. You can even do it. Check this out. This is kind of like a dilation a little bit. This is like a dilation. But check this out. I can go the other way. There we go. Now it actually crosses. Do you know what it's called when I do something like this? Check this out. There we go. Compared to the original. The original was y equals x squared plus x plus 1. Do you know what those are to each other? Going back to geometry. Getting closer. It's a reflection.
Oh, yeah.
Yeah, it's a reflection. But that's besides the point. I could do this with anything. I could change the number to here and that and that. There we go. Check that out. Actually, let me do one more thing here. Look at this. There we go. I'm doing one more little calculation there, which I'll talk about what that is in a moment. But ooh, we'll get there. We'll get there. Notice this number? You know what's so special about it? Has a certain designation to it. Let's see, 2x squared minus x minus 6 equals 0. I can factor this thing. I can actually factor it. Let's see. A times c is -12. Magic numbers, t-chart, 2x, 2x, -4 and 3. This is not what I'm teaching you today. I'm just kind of showing you this to show that the answers do indeed work the way that they should. And I get two answers, -1.5 and +2. Yay, happy day. You said that this multiplies 7 times 7. What type of number is that? It's an odd number, I know, but has a certain designation to it. We'll see. We'll see. I'll come back to this. I'll come back to this. Again, doing that factoring and solving wasn't the huge deal. She said reflection. I just couldn't see the equation you wrote. I'm sorry about that. Let me change this thing up again. Check this out. I could even do something like this, where this equation we did before, change this to a 1. There we go. Look at that number now. Look at this number now. What's so special about that number? 5 times 5. What's it called? What type of number is that? It's a perfect square. It's a perfect square. 49 was a perfect square. 25 was a perfect square. There's a certain designation that comes with that. Now, you said that that calculation, b squared minus 4ac, you said that it was a part of the quadratic formula. Do you know the other name for it? Not the formula, but for that calculation. That's okay. Okay. Let me change it again. Change it to this. Let's go with a 4. Let me go with a 0. Let me go with a -9. Check this junk out. Check this junk out. This is 4x squared minus 9. I put my b value at 0. This factors into 2x minus 3 and 2x plus 3 equals 0. And notice this number one more time. Perfect square. Yeah. What's beautiful about it is if this calculation is a perfect square, then this is factorable. If this is not a perfect square, then this is not factorable. It's so wonderful. It's so wonderful. Check this out. I want to show you one more thing on this just because I love Desmos and the way that it does things and all of its wonderfulness. First, I could do this. Someone get that? First, I could do this. I could actually turn on all 3 sliders at the same time for funsies. Let me zoom out and show you there. You can turn on all 3 sliders at the same time. It does some weird stuff. I don't even know. But Desmos has a lot of stuff with, pause that, hold on, pause. There we go. Desmos has a lot of stuff with parabolas, which is amazing. You may or may not have seen this. Marble slide, the parabolas, there we go. You may or may not have seen this in the past, but there's actually like this thing called marble slides where like you can have parabolas and actually like drop balls and try to get like the stars right there. It's like a little game that they have, which is fun. But then they have like, oh no, I can't get all the stars. But then like they have you change up the equation so that the next time you do it, hey, look, I got all the stars. Something stupid like that. Yeah, like this one, like for example, I'd be like, oh no, I can't get them all. So you have to like move stuff over. So it's like, okay, let me move it over. Let me change that to a 10. Change that to a negative. Change that to be a 10 as well. I got to move that thing up a little. Let me get rid of that. Let's launch it. Nope. Oh, see, I got to no, I got to reset that thing. Anyway, but it's like, you know, you can flip it up like that. It's so much fun. Anyway, back to this. I'm having too much fun with Desmos. One time I did a professional development where all we did was play around with Desmos for like 3 hours. So much fun. Just this thing can do everything. It's so great. I don't know if you've ever used Desmos down here. If you've ever seen the type of functions that it can do. Because it can do trig functions, it can do statistics, it can do distributions, it can do so much stuff. It's insane. It's better than any calculator. Anyway, here's what I need from you. In order to move this forward, in order to show you what's going on here, in order to see what this number has to do with anything, I'm going to need those notebooks out and open. No, why? Why? Sometimes you do, sometimes you don't. You don't really need it today. You know, some people do for whatever reason. I don't know. If you need to charge, what are you doing? What are you on, a fake phone call? Yeah, then don't answer your phone. Especially in class, don't answer your phone. It's so funny because it's like, you know, I do understand that in some families this happens, but like I've had a kid argue with me. They're just like, what if it was my mom? What if it was an emergency? If it's an emergency, they'll call the school. Well, for 12 years, I've been facing a brick wall. You know how many phone calls actually come through? Maybe 1 out of every 10. Anyway, back to this. Let's solve quadratics by the quad formula. Now, you did mention the quad formula before. Honest question. Do you have it memorized?
Squared and then like negative 4ac. No, wait, is it b square root
We'll get there.
2?
Let's take it a step at a time. First of all, I'm not going to show you the formula. Let me just show you the equation. There is the designation of the quadratic equation.
Oh my God.
The equation is everything that you guys have seen over the years. The equation is everything that we've been doing. It's just ax squared plus bx plus c. That's all that the equation is. It's from this equation that you get the values of a, b, and c that you then get to plug into the proper formula. There is something known as the discriminant, which I'm going to abbreviate as DISC, so I don't have to write out the word discriminant every single time. But the discriminant is the calculation b squared minus 4ac. This, I think, what part of it, what you were trying to remember. As a side note, you could do like 4ac or 4ca. It's the same thing. It's just that they do 4ac just for the sake of simplicity. Now, the discriminant, something that I was showing you before on Desmos, it has certain capabilities. It has certain properties that are very helpful when determining the answers to a quadratic. First of all, if your discriminant is a positive number, meaning greater than 0, then you will have 2 real solutions. I was trying to show you that on Desmos before. Now, I'm going to come back to this screen in a moment. Let me go back to Desmos just to kind of show you a little bit. Click. I'll come back to that screen in a moment. Let me just show you this again. -6. There we go. If you notice right here where my mouse is flipping around, it's a positive number, meaning you have 2 real solutions. Now, I could change that. Give me a negative number. -5. I could change it to a 5, right? This thing is not factorable. This is not factorable. What I have on the board right now is not factorable. This is x squared plus x minus 5 equals 0. You can't factor that. But it still has 2 solutions. What was the equation you wrote for discriminant? I'm going to come back to that screen in a moment. It still has 2 real solutions, even though you can't factor that. And if you notice, remember I was asking about perfect squares. That's not a perfect square, but it's positive. And because this is positive, you get 2 real solutions. Let me go back to the other screen. Flip. There we go. If, oh, wrong marker. Come here, marker. There we go. If your discriminant is equal to 0, which is entirely a possibility, then you would have 1 real solution. I have to ask you a question, though. What? Oh, you can. I'm hoping you can kind of see that. I know that glare is right in the middle. Let me move the paper over. This way. Hopefully that works a little bit better. I hope. What does it look like if a quadratic only has 1 real solution? What does it look like? No, if it were a straight line, it wouldn't be quadratic. I understand what you're saying. I understand what you're saying in the sense of straight line because, flip. Obviously, if I just had, a straight line, there's my only solution. However, that's not a quadratic. That's a linear equation. What does it look like if a quadratic only has 1 real solution? Has to have that U shape.
Oh wait, it's where it just hits it.
Like a or a like that.
Yeah.
Absolutely. Oh, good. Let me flip back to Desmos. I'll show you what this thing looks like. Flip. Let's do a -6 and a +9. There we go. Look at that. First of all, notice the discriminant right there. equal to 0. This is the equation, x squared minus 6x plus 9 equals 0. Right here, there we go. There's the only solution. Hey, can you think of two numbers that multiply to 9 but add up to negative 6? They both have to be negative. They both have to be negative because they got to multiply to a positive and add up to the negative 6. But then when you solve it, you get the same answer twice. Well, you're not. If it's the same answer twice, you're not writing it twice. You don't have to write it twice. There's only one solution, like you just said. It just comes down and touches it. But then, there comes a situation. Get rid of that dot. There we go. There comes the situation where you don't have any real solutions. And in this situation, there we go. If your discriminant is less than 0, then you will have 0 real solutions. Now I want to emphasize something very important right here. I'm putting on my serious tone to show you how important what I'm about to say is. If your discriminant is less than 0, you will have 0 real solutions for now. For now. You will have 0 real solutions for now. But next week, I am going to be teaching you numbers that are not real. What would you call a number that is not real? Some people will call it fake. Some people would call them imaginary. I would call them complex. Complex numbers have been staring you in the face this entire time. For example, what's the square root of 49? What's the square root of 49? Why? Okay. What's the square root of 144? Cool. What's the square root of negative 4? For now. You can't square root a negative for now. It's going to be great. You can't say the answer is 2 because 2 times 2 would give you positive. You can't say negative 2 because negative times a negative would give you a positive. But when I say the square root of negative 4, check this out. I'm going to blow your minds. Check this out. Check this out. Zoom in, zoom in, zoom in. Check this out. If I did right now, if I did the square root of negative 4, look what my calculator says. Non-real, right? But watch this. Ha-ha! I. It's going to be so great. I is the complex constant. I is standing in the place of the square root of negative 1. See, the thing is, you guys have been dealing with real numbers your entire life. Real numbers include counting numbers, negative numbers, fractions, pi, the square root of 2. But complex numbers exist outside of that universe. But guess what? They exist. They exist inside your universe. Believe it or not, they do. And they're going to ruin your day. At least I hope they will. So great. Anyway, back to this. It's time for the quad formula. It's time for the quad formula, the formula that you need to memorize, the formula that you need to commit to memory, the formula that you need to know how to use and when to use it. I'll break it out piece by piece. Now, first of all, it's x equals a giant fraction. Great. It starts out with something with a negative b. People always forget that negative, but it starts out with a negative b. Then it has this little symbol that reads plus or minus. It reads plus or minus because you are technically supposed to do the calculation twice. You're supposed to do the calculation once with a plus and once with a minus. That's how you get two different answers. Then there's a big old square root. Now, inside of that square root should be something that is now familiar. Inside of that square root is that calculation, b squared minus 4ac, which what did we call that? The b squared minus 4ac? We called the discriminant. It's inside that square root. And the whole thing is over 2a. Think back. Think back to elementary school. Think back to the times when you were first learning this stuff. My son's in first grade right now, and he is learning all this amazing stuff with math. He impressed me last night. He impressed me because he was doing the calculation 8 plus 7, and he was trying to do it in his head. And he was having a little trouble with it. And then as a first grader at 6 years old, he's like, oh, 8 plus 7 is 15, and he writes it down. And I'm like, how did you get that? And he said, well, 7 plus 7 is 14, and 8 is just one more. And I'm like, what an insight from a 6-year-old. That kind of blew my mind. My kid figured that out, and I'm not saying you, I'm not saying any of you, but does anyone want to admit that they still have to check the calculator for 8 plus 7? It's okay. You don't have to admit it. I've seen Algebra 2 students do that. I've seen Algebra 2 students check 6 times 2. Like, what are you doing? Anyway, back to this. I need you to think back to elementary school. There are 2 things in mathematics that you were taught never to do. There are 2 things in mathematics that you were taught never to do. One of them was taking the square root of a negative. You were taught never to take the square root of a negative because you don't get a real answer. Correct. You don't get a real answer. And if your discriminant happens to calculate to become a negative number, you are to write no real solution. For now. Oh, I'm sorry. She said she got showed up by a 6-year-old. Anyway, back to this. Now, you can't take the square root of a negative. Do you know the other thing that you were taught never to do? There was something else in elementary school that you were taught never to do when calculating math. Something very basic. Do you know what it is? In the realm of adding, subtracting, multiplying, dividing, what's something that you were taught never to do? Said, don't do this because it won't work. Ooh. What can you never divide by? You can't divide by 0. Even in upper level math, you can't divide by 0. You can't. The only way you're going to divide by 0 in this formula, ladies and gentlemen, the only way you're going to divide by 0 is if this a value was 0. The only way you're going to divide by 0 is if that a value was 0. Let me show you this. This is what we were talking about before. Remember when I asked you about the one solution and you said like a straight line? Look at this. Let me change this. Check this out. Watch what happens when it goes closer to 0. Boom. It is no longer a quadratic if your a value is 0. You can have it at 0.1, and it's like, Mr. Markey, 0.1 looks like a straight line. I know 0.1 looks like a straight line, but look, it's not. 0.1 is not a straight line. It's still a quadratic. But if I put it to 0, that thing's a straight line. It's no longer a quadratic. Your a value can never be 0. Back to this. In my notes, you're going to find this out throughout the school year. In my notes, I don't overuse stars or exclamation points. Have you ever known anybody to overuse exclamation points? I just got an email from my supervisor that had like 15 exclamation points in it. Like, okay, that's a bit much. But I don't overuse those kinds of things. So when I use a star in my notes, you better believe it's a big deal. It's October. How many stars have I used so far? Well, now here's one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 1 If you cannot solve by factoring, the quad formula will always work. If you cannot solve by factoring, the quad formula will always work. I cannot emphasize that enough. The quad formula is kind of like your last resort. And I'm going to show you a comparison between factoring and quad formula with some problems in a moment. Let's see what we got here. Somebody give me a number, any positive number. You sure? All right, we'll do 4. I was hoping to do something a bit more extreme, but we'll do 4. Here's the example. X squared minus 4x. Let me make sure this works properly. Minus 12 equals 0. Now, I got to tell you, we can solve this by factoring, but I don't want to. I want to solve by the quad formula. No, my pen. I want to solve by the quad formula. That's what I would like to do. Now, for the sake of argument, you could factor this thing into the following and get your 2 solutions. If you understand how to do factoring, if you understand how to do proper factoring, then I fully believe that factoring would be the easiest thing to do. But sometimes you can't factor. And when you can't factor, you have to rely on the quad formula. Let's go through this problem using the quad formula. Here's how I would suggest you do it. First, I would have you identify the values of A, B, and C. In this case, it's a 1x squared. So you'd have 1, -4, and -12. Please be very careful with identifying your negatives. Next, I would have you calculate the discriminant separately. To make it easier for yourself. Now, at this point, you could pretty much go to your calculator to get this answer, but let me just write it out here. I would write it out -4 squared minus 4 times 1 times -12. Tell me, what is -4 squared? Yeah, you can.
-4 squared?
Yeah.
Guessing negative. No, 16. Positive 16.
You said -16. He's saying positive 16. Let me go to my calculator. There's a point to me emphasizing this right now. -4 squared. Or -4 squared. No, the calculator's not wrong. The way that it was typed in was wrong. See, the thing is, I've seen high school students do this year in and year out. They type something into the calculator and they're like, but the calculator told me. The calculator is only as smart as the person holding it. So if you type something in wrong, it is going to be wrong. I see you there in the chat. Oh no, she retracted the message. I didn't get to read it. Anyway. Parentheses. I may have said this before, but I'm going to say this multiple times throughout the school year. Parentheses will save your life. Parentheses are like a big old hug surrounding you with all their warmth. But you got to make sure you do this correctly. So I'm going to type this in, -4 squared minus 4 times 1 times -12. Ha-ha! 64! Now, 64 is a what type of number? 64 is a what type of number? It's a perfect square. It's a perfect square. Now, I did that on purpose because this thing is indeed factorable, but let's go through this a piece at a time. So I'm going to go through the rest of the quad formula. The rest of the quad formula, x equals. Now, I'm going to read it verbally. I'm going to read this verbally, but I need you to also watch what I'm doing. Because I'm going to read the quad formula with the letters, but I'm not going to write the letters. I would say negative b plus or minus the square root of b squared minus 4ac. The whole thing is over 2 times a. Now, again, I'm going to simplify this thing down in a moment, but again, take it piece by piece. I have seen so many people mess this thing up. I have seen so many people mess this thing up because they decided at a certain point to throw the whole thing into the calculator, or they mess up one negative sign the entire way down, and it ruins their answer. You can't make that mistake. My b value is -4, and I said negative b. What do you do here? What happens here for the negative b? It will become positive. They don't always. If it's like -4, it would stay a -4. But it's the negative of -4, so yes, it will become +4. We already calculated that discriminant separately. Thankfully, it's a perfect square. We can take the square root. It'll become 8. We're also going to simplify the bottom of the fraction. 2 times 1. So we're going to get a 4 plus or minus 8, the whole thing over 2. At this point, you need to evaluate the plus or minus. At this point, you need to evaluate this problem both with the plus and separately with the minus. So I'm going to do a 4 plus 8 over 2 and a 4 minus 8 over 2, resulting in my two answers of +6 and -2. Now, clearly, I already knew that. Clearly, I already knew that based on factoring. If you had the choice of doing factoring or the quad formula, what would people typically choose? People would typically choose factoring, typically. Which brings me back to my star statement I made earlier. People would typically choose factoring, but if you can't factor, the quad formula will always work. You need to know how to do both. People would prefer I would love to do this thing with factoring and be done with it. But you need to know how to do the quad formula. The quad formula is your last resort. Let's do a problem off of that worksheet. The worksheet that I just gave you before, the worksheet that has all of those wonderful problems on it, I may only end up doing 1 or 2 problems off of it, but that's good practice for you, and I may refer to that worksheet next week. But for right now, I want you to write down number 6. I believe number 6, please tell me if I'm wrong. Is it the one that starts 15x squared? Good. Write down number 6, because we're going to do that one together. That's your choice. I'm going to put it into my notes. It's just good to have that comparison, especially if you need a little extra room, you know. But I believe, please correct me if I'm wrong, I believe it was 15x squared plus 22x equals -8. Cool. Example number 6. This looks weird. This problem looks different. Why does it look different? It has to. In order for you to continue with the problem, it has to be equal to 0. You cannot begin this process until you get one side of the problem equal to 0. Let me show you the comparison. Let me show you the comparison with factoring. The comparison with factoring is really interesting. Check this out. 15x squared plus 22x plus 8 equals 0. Just trust me when I say that 15 times 8 is 120. Can you tell me two numbers that multiply to 120 but add up to 22? You can. It's actually a lot simpler than you think. Two numbers that multiply to 120 and add up to 22. Now, 11 and 12, I believe, would be 132. No, 132? 132, yeah. Two numbers that multiply to 120, but add up to 22. Yeah. 12 and 10. By the way, remember I told you before about my kid doing 8 plus 7? You said 12 and 11, I think. First, remember 12 times 11? And I said 132. I think I got that right. Maybe it was 100 and... Oh, I was thinking 11 in my head. My goodness. Anyway, it's like 12 times 12 is 144. But if you go 12 times 11, then you're taking away a group of 12. So it would go from 144 down to 132. That's just how I think about it in my head. 15x and 15x. Simplify, simplify, divide by 5, divide by 5, divide by 3, divide by 3. It'd be a 5x plus 4 and a 3x plus 2 equals 0, which would get you an answer of negative 4/5 and negative 2/3. That's a little bit more complicated, but it's still doable using the Tucker method of factoring. But that's not the purpose of today. The purpose of today was to focus on the quad formula. So I'm going to identify A, B, and C. 15, 22, and positive 8, because you had to have it equal to 0. I'm going to do B squared minus 4AC. Oh my gosh, 22 squared minus 4 times 15 times 8. That's going to be horrendous. That is going to be horrendous. 22 squared minus 4 times 15 times 8. Oh, holy crap. That worked out really nice. It's got a 4. Indeed. You have to know how to type it into the calculator. I don't trust the calculator. I really don't trust them as far as I can throw them, which is not that far. But you really have to be careful with your calculator. Say what about being careful? Oh, yeah, dude, you're going to hear me say that 1,000 times. I have a lot of catchphrases. In my head, when I say the catchphrases, I hear the audience in my head. Like a TV show. Anywho, it's negative B plus or minus the square root of the discriminant, which we just calculated separately. The whole thing divided by 2 times A. And I'm going to break this down piece by piece. Negative 22 plus or minus 2 over 30. All right. So I could do negative 22 plus 2, which would give me negative 20 over 30. And I could do negative 22 minus 2, which would give me negative 24 over 30. Oh, look at that. We got the same answers. Some people prefer factoring. Some people prefer quad formula. In my opinion, factoring is a lot easier. Quad formula is a bit more tedious, but they get you the same answers. Somebody give me a single digit number. Are you sure? Could we do 1? Yeah, let's do 1. We'll do 1. Let's do 1. Move that up. Example. Give me another single digit number that's not 1. Will 3 work? Yeah, I think 3 will work. X squared minus 3x plus 1 equals 0. Get ready. I got 2 more good examples to show you. so excited. Well, here's what it comes down to. The only other method that you guys have for solving these right now is factoring, right? What's A times C? It's not factorable. A times C would get you a 1. There's no way you can get it to two numbers that multiply to 1 and add up to -3. You can't factor it, but you still have to solve it. So, A, B, and C. You still got to solve it. Even if it's not factorable, frozen, even if it's not factorable, you can still solve it. B squared minus 4AC would be -3 squared minus 4 times 1 times 1. All right. That'll give me a 5. That still works, I guess. Yeah. 5 as a discriminant, 5 as your B squared minus 4AC. I can still do this problem. Let's see. -B plus or minus the square root of the discriminant all over 2 times 1 gets me 3 plus or minus root 5 over 2. What's the square root of 5? Do you know it off the top of your heads? I don't know anyone that really does. Yeah. No, it would not exactly be 2.5. No. Because check this out. The reason why that wouldn't work is because 2.5 squared gives you that. Yeah. No, it's like 2.24. See, the thing is, did you ever have to do the Pythagorean theorem in geometry? And did you ever have to like simplify radicals? You can't simplify the square root of 5. You can't simplify the square root of 5. We're going to focus on simplifying things like this next week. But here's the deal. That's all you can do. You could if you wanted to. You could do this. But that's also the same thing. It's also the same thing. Let me show you something in the calculator. This is really messed up. Check this out. Let me go to x squared minus 3x plus 1. This is the exact example you just had. This is the exact example. I'm going to erase that stuff on the board in a moment. Check this out. Graph. Look at that. Let's see what she wrote. Oh, I'm sorry. You did that so fast. I'm going to check the chat in a minute. Which part specifically? Are you referring to the problem that's still up there, or are you referring to the previous problem? And I'll come check back in a minute. Tell me, this example that we just did, does it have two real solutions? It does, because it crosses the x-axis. That one. Oh, this one. Okay, good, because I'm going to zoom back out on this one in a moment. It crosses twice. But the thing is, check this out. You see the answer that is written right here that I have circled, 3 plus or minus root 5 over 2. Watch this. Trace. 3 plus root 5 over 2. What these graphing calculators allow me to do is to type in a value for x. And if I hit enter on this right now, then it will calculate exactly what the x value and the y value is. Now, I can't do plus or minus in the calculator at the same time. I can't do plus or minus. I can only do one at a time. So for now, we'll do plus, and then I'll come back and do minus. But if I hit enter on this, look at that y value. Look at that y value. This is the exact number. This is the y value indicating that it is an x-intercept. Let me do it again, but with the minus. Give me 1 second. Let me write this and I'll give you a pass. Boom. 3 minus root 5 over 2. My pen. I had a pen here somewhere. No, do it in pen. I had a pen somewhere. Whatever. We'll use this one. There you go. But if I see, oh no, my pen. There we go. If I have 3 minus root 5 over 2, you can see it right there, still blinking with a y value of 2. It's the exact answer. It is the absolute exact answer. So now in the chat, I know you said that I went a little bit too fast on this. I'll leave this up here for a moment. I do have one more example I want to go over, but I'm going to leave this up for a moment just to kind of give this explanation. You calculate the discriminant separately. You can see it right there, equaling 5. Negative 3 squared is 9 minus 4 times 1 times 1. Be 9 minus 4 is 5. I plug the 5 in where it should go. I should plug the 5 in where it should go. Negative b, which is the negative of negative 3, plus or minus root 5 over 2 times 1. I'm just using the quad formula to get that thing going. The negative of negative 3, not supposed to be in the live stream. The negative of negative 3 is positive, plus or minus root 5 over 2. That one. Are you able to see that okay? Because I'm going to put up another problem just to wrap up class. She said hi to Declan. You know, it's funny. When I was in high school and I took a math class, there are several math classes that I legitimately slept the whole way through. Just slept. Some of them I did really good in. Some of them I did terrible in. Geometry, I sucked at geometry. Just sucked at it. I slept the whole way through and I got like C's and D's. Then I got to algebra 2 and trigonometry. And I was like, oh, this is easy. And I just kind of slept through the class and got A's. But then I got to calculus. Turns out you can't sleep through calculus. I learned that the hard way. I still got a 4 in the AP test. You guys know about AP grading? AP grading, you take that AP test, you can either get a 1, 2, 3, 4, or 5. 5 being a perfect score, 3, 4, and 5 be passing. Anyway. Let's see. I'm going to do something here. Last example of the day. X squared minus 3x plus 5 equals 0. Let me see if that works properly. I want it to work properly. Yep, and it will work exactly the way that I want it to. So for this problem, I'm going to calculate the discriminant separately, just as I always have. 1, negative 3, and 5. Negative 3 squared minus 4 times a times c gets me, oh man, negative 11. I'm going to double check that. Yeah, my goodness. Someone remind me, what happens if I have a negative discriminant? What is the designation for a negative discriminant? How about this? Where does the discriminant go in the quad formula? Where does the discriminant go in the quad formula? Ooh. Correct. Where does the discriminant go in the quad formula? Ah, she said it. She said it. I'll come back in a minute. Hold on. She said it in the chat. Now, you said there would be no real solutions, which I agree with you wholeheartedly. But she said something that was a bit more correct. She said no real solutions for now. And that's the key, ladies and gentlemen. For now, for right now, if you get a negative discriminant, there will be no real solutions. But next week, I will be showing you what happens. I will be showing you next week what happens when we are allowed to take the square root of a negative number. And that's actually what I was aiming at. Where does the discriminant go in the quad formula? I was asking him that question before you came back. Do you know where the discriminant goes in the quad formula? In the square root. And if you have a negative discriminant, you'd be taking the square root of a negative, which forces, for now, no real solutions. Check this out. Are you sure? No, I'm going to show you anyway. So you would end up with something like this, which in reality would become something like this. I'm so excited. You can't take away my excitement. Yeah, I saw your notes. You can't take away my excitement. Oh, I can. In my mind, I can. I can erase it from my memory. Yeah, exactly. Like I said, you guys are just figments of my imagination. Anyway, ladies and gentlemen, do not forget the things that are due. You are, though. How do you know you're real? Exactly. Now, don't forget the Edge Elastic assignment due tomorrow. Do not forget your project due Monday. If you have any questions, make sure you email me. Hey, look at that. I know it's real.